Hey guys, welcome to Trig Lesson 3. Today we're going to be learning the 6 trigonometric functions and how we can apply those to calculate different sides of a right angle triangle. We'll cover angles in the next one, so how we can use sides to calculate angle, the angle. So that means we're going to be talking about inverse functions. But today we're just going to be talking about the basic 6 trig functions without the inverse. So that means we're using the angle to calculate sides. So let's get right into it. So we have this expression here called SOHCAHTOA. Basically, it tells us how we can use the angle to calculate a different side, or when we can use the angle to calculate no, wait, yeah, so when we use the angle to calculate a side, or use the side to calculate angle. So we have sine, cosine, tangent. You should be able to find each of those in your calculator. So we can use these expressions. So when we actually sort of expand them, then we write sine theta or cos theta or tan theta. So sine theta as O over H. But when we actually have our right angle triangle, then say that that's 42, then we're going to replace it. We're going to write sine theta equals, no, sorry, my bad, sine 42 equals O over H. Okay, so now talking about the 6 trig functions, sine is equal to the opposite of the hypotenuse. And then we have the cos adjacent over hypotenuse. And then we have tan theta, or just tangent, which is opposite over adjacent. No. So, if you haven't gotten this down already, note this down somewhere, or just remember the acronym SOHCAHTOA. It really does help. So yeah. So pause the video, get down the notes, and then what we're gonna do is we're gonna move straight into some problems because basically that's all you need. I'm gonna put up one problem. We're gonna solve that together, and then same applies for the first 2 problems. We're gonna solve those together as they involve both multiplication and division. So I'm just going to teach you a quick handy tip, and then I'll put up two more questions, and then if you guys can solve that, then that would be great. So let's get right into it. Okay, so our first problem, I know that's a little too big. Why? No, I'd like it to go that way. And we have a 90-degree joint. We have this angle theta here, and let's substitute that in for 72 degrees, and we're gonna say this side is x and this length here is 15.8 meters. So calculate the answer to this x. Okay, oh sorry, no, I'll be teaching you guys how to do it actually. So first of all, we have to label the sides, which is from lesson 1. So notice that the hypotenuse actually isn't labeled. That really just means you don't need the hypotenuse for this because you're already looking for x. So that's that, and we have this opposite side here. So first of all, we have got our opposite, we have got our adjacent. So opposite and adjacent of the, so is for tan. So we're going to be solving for tangent. Sorry, no, for adjacent, but using this tangent formula uh, for this problem here. So now let's get right into it. So we know that tan 72 equals opposite, which is 15.8 over x, and then what we're just basically going to do here is we're going to swap these around. So x will go into the place of tan will go into the place of x. So x equals 15.8 over the tan of 72. Now here's a quick tip. So if x is on the denominator, then it's always division. Say if it was this problem here, then what we're gonna do is we're gonna do x equals tan 71 bracket 15. So if it's in the denominator, you multiply. If the whole number is in the denominator and x is in the numerator, then you multiply. If it was the reciprocal of this 15.8 over x, then you divide, which is basically this here. Sorry, where I'm a bit lost. Okay, so if x is the denominator, then you divide. If x is the numerator, then you multiply. So that's that. But in the next problem, that's exactly what we're going to cover. So that's just a quick thing it's best to have in your mind. So then we're just going to evaluate this here. And so x equals 15.8 divided by the tan of. Okay, so if you got an answer of x equals 5.134 meters, then well done. So that you've got that part. So now let's move on to the next question. So the next question I'd like you to solve is this one here. Alright, so we're gonna have angle as 38 degrees. So for x, and we're gonna label that 6 centimeters. And I'm gonna now solve this question with you guys. So we once again labeling your sides. We have opposite, we have hypotenuse. So SOHCAHTOA. And if you selected sine, if you solved this before and you selected sine, well done. But so as you can see, we have our opposite and we have a hypotenuse. So sine is opposite over hypotenuse. So sine of 38 is equal to x over 6. And then basically same thing. But what we're going to do instead is we're going to have to multiply, because as you can see, x is in the numerator, not the denominator. So that means that we're going to write x equals sine 38 times 6. And if you got x to be 3.694 meters, then well done. So now I'm going to give you guys two more problems, and I'd like you to solve it by yourselves. Pause the video and then solve it, and then I'll give the answers out. So the first one should be relatively easy. So we just have a right angle triangle, and this angle here is 33 degrees, and we have this. I'd like to calculate for this length here, and this one will be 9 meters. So now working it out, we're just going to label a right angle triangle. So we have the opposite, we have the hypotenuse. So sine of the opposite, which is sine 33 equals 9 over x. And then we're going to do x equals 9 over the sine of 33, and then x equals 9 divided by the sine of 33. And if you got 16.525 meters, then well done. So now I'm just gonna put up one more problem, and if you guys can solve that, then you've really basically just gotten trigonometry, the trigonometric function part 2. Alright, so let's put in a problem. So let's take a look where that is 50 degrees. Both base angles are equal, so that means that this one will be 50 degrees also. And we're gonna label this side R and S, and I'll call this side B. And this length here will be 25 meters. So will this side here. So that means it's 25 meters. I'll still put it there. Anyway, so solve this question and then I'll solve it too. Okay, so first of all, what a strategy that I would use to solve this is I'd split the triangle. So that means I make a 90-degree joint here. So that means that overall, okay, so that's 25, 50. All right, so that means that our other right angle triangle, our halved right angle triangle will appear like this. 25, that's terrible. 25, 50 degrees. And we are to solve solve the adjacent side. So we'll just label that X. And so we have the adjacent, we have hypotenuse, that means we use cos theta, so we use cos of 50 is equal to X over 25, and then X is equal to cos 50 bracket 25, and X equals what is it? Cos 50 bracket 25. If you got 16.07 meters, then if you solved it my way, and if you got 16.07, then that is correct for step 1. Step 2, but remember, this is only half, so we need a double X. So that means 2X will be this number times 2, which is 32.14 meters. Henceforth, looking back at that right angle triangle we actually had initially, and that is 50, 25, then, and going from R to S, and if you got R to S to be 32.14 meters, then well done. You've basically got this trigonometric function section, and well done, and that's pretty good to hear. So if you got it correct, so yeah, thanks for attending. Like and subscribe.